Hi guys, and welcome back to our third lesson on factorization. So moving on to our third type of factorization, which is referred to as difference of two squares. Now, difference of two squares, you're going to find these questions that I'm working with. It's exercise 4.3 on page 32. Again, if you don't have the notes, questions are still on the board. We're kind of jumping between them. So guys, to start off here, difference of two squares is a very distinctive type of factorization. So what you probably found was that grouping and highest common factor, there was overlap between the two. Here, difference of two squares is very distinct. Why? Well, first of all, there has to be two terms. There has to be a minus in the middle. And for any coefficient, you have to be able to find the square root. Also, you have to have two even pairs. We'll say even pairs for the moment, a little bit different than that. Now, I have a little test when you're asked to factorize with difference of two squares. If it fits into this model, it's difference of two squares. If it doesn't, it's not. Because oftentimes students look at this and they say, that looks like highest common factor, Tracy. So we have bracket 2b squared minus bracket 2b squared. Now, if I can get this to fit in there, then it's difference of two squares. So first of all, let's check. Is there a minus in the middle? Yes, there is. Always has to be a minus in the middle in two terms. Can I say something to be squared is x squared? Well, yeah, x to be squared is x squared. And can I say something squared is 49? Of course I can. What is the square root of 49? Well, the square root of 49 is 7, which tells me that 7 squared is 49. Now that fits into that model perfectly, but it's not my answer. What I now need to do is open two brackets, place a plus in one, minus in the other. This is going to be my first term in both x, and this here is going to be my second term, 7. And that there is my answer. Second one, e. So we're jumping down as far as e. Again, I'm choosing these questions intentionally. So first of all here, let's check if it's difference of two squares, and if it's not, it's more than likely highest common factor. So let's open our brackets and pop down our test. So to start off here, step number 1. Is there two terms? Yes, there is. 1, 2. Is there a minus sitting in the middle? Yes, there is. Here, this is a little bit more complicated because we have coefficients in front of both variables. However, let's take a little look. Can I find the square root of 9? Yeah, that's 3. I'm just going to pop these up first. And can I find the square root of 16? The square root of 16 is 4. So what to be squared will give me 9x squared? Well, obviously, 3x, all to be squared, gives me 9x squared. There's a minus sitting in the middle. And finally down here, 16y squared. 4y, again, square root of 16 is 4. All to be squared will give me 16y squared. It fits in that model. So here, what I'm going to do is I'm going to place a plus in my first bracket, a minus in my second. Here, I'm going to have 3x, and 3x, and 4y, and 4y. My answer. And if I want to take a minute with that answer, obviously I can multiply it out or expand it out, and I should get my original equation. Moving on to our third example, f. Now for f in this case here, f is x squared minus 16, and we're asked to factorize. So again, two terms. Will it fit into this little model here? This is my little test. If it does, it's difference of two squares. If not, I choose a different type of factorization. First of all, is there a minus in the middle? Yes, there is. Can I say x to be squared is x squared? Yes, I can. And can I find the square root of 16? Square root of 16 is 4, which means 4 to be squared is 16. Sorry, I pointed there. I meant to point over here. So once it fits in that test, I open my two brackets. I place a plus in one, minus in the other. It doesn't actually matter which way around that goes. X and X, 4 and 4. And that there is my answer. That's actually a little bit simpler than our previous one. So coming across to G, and again, we're on page number 33 at the moment. So G, we're asked to factorize x squared minus 81y to the power of 4. Now, this, again, you're not going to see very frequently on a paper, but it is on our course. So we're just going to look at one when it's to the power of 4. I'm not going to spend too much time on it because we will look at indices later on. So here, let's check if it's difference of two squares. something to be squared minus something to be squared. I shouldn't be saying something about any of it. So here, is there a minus in the middle? Yes, there is. Can I find the square root of 81? Well, the square root of 81, just to get the prep work done, is 9. Now, I want to remind you of this, that y squared, all to be squared, will give me y to the power of 4, because it's 2 plus 2 when you square it out. So just to get that there. So, minus in the middle, x to be squared is x squared, and 9 y squared, all to be squared, will give me 81 to the power of 4. So here I'm going to open my two brackets, plus in one, minus in the other, x and x, 9y squared, and 9y squared. The very last one, h, that's definitely the most complicated. For h here, this is one that tricks students out all the time. So here, I'm going to open, or pop down my test, I should say. So something to be squared minus something to be squared, does it fit in? Well, first of all, is there a minus in the middle? Yes, there is. Can I say x to be squared is x squared? Yes, I can. And this is where some people get confused. What is the square root of 1? Can I get the square root of 1? Yes, you can. Check it on your calculators if you don't believe me. It is 1. The square root of 1 is 1, which means 1 to be squared gives me 1. Here, open my brackets, place a plus in one and a minus in the other. X and x, 1 and 1. Now that there is our third type of factorisation, which is difference of two squares. We're going to move on to factorising our quadratic trinomials next.